Hello, and thank you for attending my talk, Comparing AWS Deployment Tools to Manage Multiple Accounts. My name is Paul Bayer. I'm with ProServe. I'm one of the principal cloud infrastructure architects, and I'm going to talk to you today about multiple deployment tools. Are you in the right place? Well, this is going to be a 300 level talk. I'm going to be talking about deployment tools that are above and beyond that which can be supported by AWS service teams or support. So some familiarity with AWS technologies is assumed. If there are any questions, please contact professional services. So today we're going to begin by talking about customer environments, some example customer environments. I've got 3 stories to tell you about how 3 different customers became successful using these tools. We'll talk about the individual tools they used and how they decided which tool to use. Then we'll go in depth about individual customers and how they use those tools to achieve success in their environment. Now, the deployment tools we're going to talk about aren't all supported by Amazon. Some are third party. There is no such thing as a comprehensive listing of everything, so therefore I do have a list at the end of this talk with links for you to connect and check out. The customers who use these tools have found that they solved their problems. By the time you see this talk, there may be additional features above and beyond what I've been able to discuss. And now we'll talk about customer environments. We'll go through each one, and then I'll show you all 3 together. So Anna represents the sustain model. This is sometimes called legacy. This is a lift and shift model. This group uses their own tool sets. They're all separate. There are application teams that do the engineering. Different teams handle the operations. The platform team is also split into platform engineering as well as platform operations. When they do a deployment, it's typically a very large undertaking. They usually use a weekend to do it. It requires everybody to get together and do a war room situation. That's how they have the application teams and the operation teams, the platform teams, the operation platforms. Everybody's got to get together, and this works for them, right? They've been doing this for years. They have a very successful product. However, they do have some difficulty with scalability. This is difficult for them to do ad hoc. It requires a lot of planning, a lot of scheduling. Everyone's got to be involved. And so the application team has trouble doing individual rollouts whenever they want because they require so many people. It's such a heavy undertaking. Now, Bob represents the cloud ops. They're in the cloud. They're using the cloud. They've put their application teams together, their platform teams together. There's really no difference. They're not as siloed as Anna. They deploy infrastructure. The cloud team deploys the infrastructure for the application team to use, and that works for them. The difficulty they have sometimes is in development agility. If the application team requires certain infrastructure or resources to be created, they have to wait for the platform team to create those things for them. So they miss some agility. There's a lot of back and forth required. Sometimes the platform team needs additional parameters or additional information as to what to create, and the application team needs to supply that. So it does slow things down, although they are able to deploy more often than once every quarter, right? They're more like once every week or every couple of weeks, but sometimes they want to go even faster. And the third environment we have is Carlos, that represents DevOps, right? In this way, the application team not only manages their application, writes their application, but they also handle a large part of the platform itself. They may have their own pipelines. Different application teams may have different pipelines, and the platform team really is just responsible for ensuring that very low-level infrastructure is appropriate for the application team. So things like networking, transit gateways, direct connect, that's not going to be done by the application team. That's got to be already prepared. So that's what the platform engineering team does in this case. The difficulty they have, of course, is that the platform team is concerned about governance. They wonder whether all of these pipelines are actually pushing forth the appropriate level of controls and governance for every piece of code. Since the code is being updated very often, application teams can create and destroy their own infrastructure like EC2 instances or EKS clusters, Kubernetes. The platform team loses some visibility into whether that's being done up to standard. So they lose a little bit of governance. So to look at all three of these application environments together, we've got the sustain, right, where everybody's kind of siloed, but this works for them. We've got the cloud ops, where the platform team creates the infrastructure necessary to run the application, and the application team creates that application and deploys it themselves. And then we've got the DevOps, where the application team does quite a lot and just relies on the platform team for just the lowest level pieces. So now we're going to talk a little bit about what tools are available to help all of these teams become even more successful in the environments that they're in. Right? We're not trying to push everyone to a single type of environment. We think that application teams and platform teams do know what's best for them. So we try and make available tools that meet our customers where they are. Okay. So the tools that we're going to discuss are, as far as the AWS service, we're going to talk about AWS CloudFormation, both stacks and stack sets. The open source tools we're going to talk about, again, the third party, is a few tools called together Service Catalog Tools, and another tool called AWS Deployment Framework. I know it has AWS in the name, but the actual tool name is the AWS Deployment Framework. That's a third-party tool. So now we're going to go a little deeper into CloudFormation stacks and stack sets. So CloudFormation stacks are a set of code that, given individual accounts, instantiates resources in that account, right? So you've probably heard of CloudFormation as a language, and the stack is a set of those instructions, and it instantiates infrastructure in that account. Stack sets are a collection of these templates and a collection of accounts and regions where this template would be applied. So in the diagram I have showing here, we have a CloudFormation stack set that creates global resources like an IAM role, and that might be applied to multiple accounts, although since it's global, only one region. We can also have a CloudFormation stack set that instantiates a Lambda function, and because that is regional, we would apply it to multiple accounts, right? Account 1 and account 2 in this diagram here, but also in multiple regions. So a stack set is able to instantiate resources in multiple accounts and multiple regions. A point to note is that when a stack set is instantiated, when it pushes out that template into the various accounts and regions as a stack, those resources are instantiated immediately. So if I push out a role, that role is instantiated immediately. If I push out a Lambda function, that Lambda function is instantiated immediately. This allows the platform team to push out things like VPCs or default roles, and we're going to look at this tool and see how it can be used to help Anna, in our first example, push out resources to various accounts and teams. The next tool we're going to look at is a tool called Service Catalog Tools. Now, this is different than Service Catalog, the AWS Service Catalog. This is a third-party tool called Service Catalog Tools. It's actually made up of two different pieces, the first of which is called Service Catalog Factory. Service Catalog Factory is the tool that allows templates, products, to be created within Service Catalog and pushed out to various accounts. So we would create a product within Service Catalog, and using Service Catalog Factory, we would copy this product and portfolio from a hub account to multiple regions within that same account. And then next, we would use Service Catalog Puppet to instantiate, to create those products and portfolios in multiple accounts within those regions. So again, from this hub account, we push out products and portfolios through Service Catalog, using Service Catalog, and we push that out to the member accounts. So in the member accounts, in the member regions, we push that out. And these products and portfolios are not necessarily instantiated immediately, right? They can be if they are mandatory, but if they're optional, they're listed in the Service Catalog, and the application teams within those accounts and within those regions are able to pick and choose what infrastructure, what products they would like to instantiate on their own. Okay, so again, Service Catalog Tools pushes out products and portfolios to multiple accounts and regions and allows those teams to have a self-service model where they pick and choose what infrastructure they'd like to instantiate. So if we take an example like a VPC, there could be 3 or 4 or 5 different products that all represent a VPC. That VPC would have been created by a platform team, that product, and pushed out to an application team's account in a specific region where that application team can decide of the many optional products they'd like to pick, which one they'd like to instantiate. The next tool we're going to talk about is the AWS Deployment Factory. And again, this is a third-party tool. It has two pieces as well. The first part is account bootstrapping, where it creates the deployment and the developer account. So the developer's account holds on to the code that a developer would want pushed out, and then the deployment account, it holds on to a pipeline or creates a pipeline, and look based on the developer's code can push out that developer's code into the necessary accounts for that developer. So the AWS Deployment Framework addresses that third case where the platform team is comfortable creating that underlying structure and the application team is comfortable writing templates to allow themselves to create their own infrastructure. But in this way, the pipeline itself is now the method by which this platform team sees that the application team is doing the right thing. It gives them a level of governance because they create and they maintain the pipeline, and they can insert governance, they can insert compliance checks, and we'll talk more about that in a moment. And again, this is the second piece of the application framework or the deployment framework, where the pipeline operations, this is the account where the deployment deploys the developer's code into the specified target. So if the developer has a development account or if they have a production account, they specify that as a target, and the deployment tool, which they don't have complete control over, will pick up their code from their repository and will push it out to multiple accounts as per their configuration. Now we're going to talk a little bit about matching the tooling of these tools to the right use case. Right? I've got a flow chart here where I'm going to talk about how to make the decision for yourself or for your customers as to which tool best fits the scenarios we've talked about. So in this diagram, we start at the Start button, right? And the first question is, does the application development team have the capability of deploying their own infrastructure? Okay, if they do have their ability, they would go to the right. But if they don't have their own ability to deploy their own infrastructure, all right, if they are limited in that way, we go to the second box. So does the developer team, are they allowed to pick the resources that they would like to use? Do they have a self-service ability? If they do have the right to have self-service, if they do have the right to pick and choose which, say, VPC or which types of infrastructure they're allowed to instantiate, then we would recommend using AWS Service Catalog tools. Okay, the Service Catalog tools would allow them the ability to pick and choose from pre-created products and portfolios, and would give them that self-service ability to instantiate what they needed. Now, if they don't have the ability to use self-service, if they are restricted from that, then we would look to the left. In AWS, CloudFormation stack sets would be the tool that we chose, where they ask specifically to the platform team that they'd like certain infrastructure created, and the platform team would create that specific infrastructure for them as needed. Again, in a war room scenario, we're always using infrastructure as code, and when needed, the platform team would be responsible and accountable for creating that template and pushing that out. Now, if we go back up top, again, if the app team does have the right to instantiate their own infrastructure at of a certain type, we would then recommend the AWS Deployment Framework deployment tool. This allows the application account team, or the application team, to push out their own templates, their own code into various accounts, and they would be responsible. They would be permissioned to only apply code to their own accounts, and their deployment framework would manage picking up the code that they had put probably into a code commit repository and push that code into defined accounts and defined regions for them. In the next slide, we're going to talk specifically about ANA and the CloudFormation stack sets. So again, we're looking at the first example, first application environment with ANA, where CloudFormation stack sets is the right tool for them. We start with the application engineering team, where they would submit requests to the platform team for what kind of infrastructure they needed. They might even write the application code to use that provided infrastructure. Again, they would write the application code to use the infrastructure that they've requested. Then the platform engineering team would write those templates for that infrastructure, again, infrastructure as code, and they would use those stack sets, and they would push out that infrastructure into the various accounts that the application engineering team requested. Why do I say stack sets? Because if the application engineering team has both a dev, test, and prod environment, then the templates can be used, the templates that are used would be the exact same templates that push infrastructure to dev, to UAT, and to prod, right? We can be sure that all environments are the same, and we can ensure that all the code is the same. So from a compliance perspective, there's no question as to whether the prod and the development environment are the same, are using the same environment. So then we get down to the cloud platform operations. Platform operations would take the code that platform engineering would have written, and they can apply that to the stack sets. Again, updating the template that's applied and having that template be pushed out to the individual accounts and the stacks themselves. And then at the application operations level, once that new infrastructure was pushed out, the application operations folks would see that infrastructure be applied, and then could apply their own or deploy their own application as they normally do. With Service Catalog tools, in the second example with Bob we look at the application engineering team first again. They submit a request to the platform team for infrastructure, but they would be able to choose from a menu of infrastructure that had already been created for what might best fit their needs. So they might be allowed to write that infrastructure code and submit it to the platform team. And if the platform team agrees that this is a good piece of code and it's good infrastructure and has proper compliance, they can then push that out into the service catalog, push that into the accounts for that application engineering team without any concern about whether it was the right timing. Because again, only mandatory products would be instantiated immediately. Products that can be picked from would be put into a menu, into a catalog, and then could be instantiated as needed. So again, we can have 5 different VPC types, and the application team would pick only that VPC type that was appropriate for them. The platform engineering team would be the ones that wrote those templates, all right, for the infrastructure. And if in a crowdsourced environment, they could even solicit infrastructure templates from their application teams. Again, some people are a little further along than others, and they would provide portfolios to all of these accounts with both, as we said, mandatory as well as optional components to be picked and chosen as needed. And finally, with the third environment, Carlos, we look at this a little bit differently. The platform engineering team would create and secure standardized pipelines and embed their own compliance as code or infrastructure as code checking into those pipelines. They're only going to enable those pipelines to do that as a permission, would only enable them to do that which they are already allowed to do. So least privilege is honored here. And then the application engineering team would create their own infrastructure as code, would create their own application templates, and would be able to push all of these infrastructure and application through the same pipeline, or if they chose a different pipeline, that's okay too. But the infrastructure would be pushed out through this framework, the deployment factory framework, and the permissions of the pipeline would be allowed to push that code into the end application accounts. The reason this works so well is because the application team is now not limited to waiting on anyone else. They can release multiple times a day if they chose to, as often as that pipeline can run. They are not dependent on the platform engineering team for writing up a template, updating the template with a new feature. As long as that the deployment pipeline has the right to apply, instantiate this particular service or in this particular account, then they're going to be allowed to deploy that infrastructure as code as necessary. So, in summary, we talked about a number of different tools and solutions. We talked about the AWS services, CloudFormation stacks and stack sets, and here are some links to more information about stacks and stack sets. We did touch upon CloudFormation Guard as the tool that would be embedded within the pipelines to ensure compliance. We talked about open source tools, Service Catalog Factory and Puppet, as well as the AWS deployment framework. And again, links are here on the page. Lastly, I have a call to action for you. Look at your organization among these 3 different success stories and decide which of these environments most closely resembles your environment. Is your environment one that has multiple different silos where the deployment, platform engineering, platform operations, application engineering, application operations are all separate and have different specialties? If so, CloudFormation stack sets might be the best thing for you. Is your environment where the application team handles just the application and has to ask the platform engineering team to create infrastructure for them? In that case, service catalog tools, both Factory and Puppet, might be best for you. Is your environment much more DevOps? If so, the AWS deployment framework might be the best choice for you, because that allows for a pipeline that is standardized across multiple application teams, along with the compliance embedded in using the CloudFormation Guard. So find your own environment, find your own organization among these three success stories. Download the tools that you've seen, and then establish a close working relationship with your customers so that you can grow in the AWS cloud and potentially move ahead in your maturity from using just the stack sets to service catalog tools and enable a level of self-service. And then, of course, into the deployment framework, where you're enabling a lot of self-service by making the application teams not only responsible, but also accountable and able to create their own infrastructure. Thank you very much. This is the end of my talk. I hope you found the information very interesting and successful for you. And please remember to complete the session survey. Thank you very much. Have a great day.